So before we move on to Apex itself, I want to give you a little bit of context because I think Apex must make sense for what it is in the current state. There is a very cool presentation by Matt Stella talking a lot about what Apex is and why Apex is needed. But I want to go a different path here to show Apex in a different perspective that for me makes more sense. Of course, the need for avoiding all those time dependencies that the former KineFX systems does was something important. That's one of the reasons that Apex was created. But why it is this way? Of course, the guys at SideFX, they are smarter than me, and probably there are other reasons or far more reasons that I can imagine, but I want to give you some reasons to make some sense on this general concept of Apex. And for this, we will talk first about compiled blocks. So this is a compiled block. I hope you have at least a general idea about what it is. So I'm using this attribute adjust dictionary to create these key value pairs that you can see here as a detail attribute. And I'm using this to drive the values inside the code. So that's it. If you need several of this and you can't make it for some reason in a for loop, what most users will do is either duplicating everything. I think that's the worst idea, because if you add some functionality in one of them, that functionality won't be inherited by the other ones. The second option would be creating an HDA, but HDAs, they take some time to build, they take some time to create the UI. So I think for this situation, it would be a waste of time. For me, compiled blocks for a lot of situations, they are a faster approach than HDAs. So what I have here is this invoke compiled block that is invoking the same code, but applying to a different input. So that's what you can see here. It's a totally different input. And therefore, if we add some functionality here, let's, for instance, extrude this guy. Let's add some normals. And of course, it's inherited this functionality. So this is a compiled block. And it has been for quite some time this idea of that you can see here in this node attribute from parameters, this idea of converting nodes or operators into geometry. That's what we are seeing here. So what we have here is the same structure, but as geometry. So if you see the attributes, you see there is this category, there is SOPs. So these points, each point is representing, in this case, a SOP node. And as you can see here, they have colors. Let me pin this. Let me change this color to red. And for some reason, should have. Where is this nodes? Polystrode. Yeah, strangely enough, it didn't. Oh yeah, it has here, I think. Let me pin this again. Let's see. Yeah, for some reason it's not updating. Not sure why. Oh no, now it's updated. It's just a matter of how it works. Although I think it should have updated, but anyway, let's change this to red. And if I disable this, you see it changed the values here. So it is replicating this logic here into geometry. And one usage of this is that your nodes are not tied to a heap file anymore. So one usage of this would be saving this code as geometry, and therefore you'd be able to run it outside your heap file. And for instance, that's exactly what Rust procedurals do in Solaris. It runs a SOP network that was previously saved as geometry, get the result, and here, if I'm not mistaken, that is delivered to Hydra, and Hydra delivers it to the render. So one of the beauty of this workflow is that it works with any render that is rendered through Husk, and you can, in theory, it's today is not so simple, but in theory you could generate a lot of geometry at render time using this approach, and therefore you could have lightweight USDs because just at render time you would generate or run a complex or heavy weight network. And I hope you can start to see the possibilities this kind of feature, this kind of technology can bring us. And in practice, let me show you. Here we have our graph. Each point represents uh, an operator in your network or a node, and the values of its parameters are represented by this attribute, the params attribute. It's a dictionary, and the key is the name of the parameter, and the value is the value of that parameter. So we can get the result by using this invoke graph node here. And since the parameters are stored as attributes, if we change the attribute or the attributes in general, you can change the parameters of each node. And that is the basic idea, the basic concept of storing geometry as, or sorry, storing your operators as geometry. A lot of possibilities can be opened because of this feature. Right now, I think only SOP operators can be run using or can be saved as geometry, at least like this. But then comes Apex. So Apex, I think it inherited this same idea of storing the code as geometry. And Apex in general, it allows us to start using other networks, or at least in theory, in this same manner. In this board, you can have a general idea on or where Apex stands right now. And I believe it will stay this way. And let me tell you why. At our lowest level, we have VEX and VOPs because we are dealing with the data in detail, being in SOPs or in geometry. We are dealing with points and vertices and primitives and so on and so forth. In things like chops, you are working on samples. In cops, you are working on pixels. So you are working with data in its finest detail. At the highest level, we have most contexts because we're dealing with data in general. We have operators that do stuff or some logic for a lot of data. For instance, in COPS, we can, as an example, think about a blur operator where it blurs your image or a portion of your image if you are masking. And this is possible because it's operating in a broader data. And besides that, we have all those nice UI features to work this way. So besides the broader approach, we have as well all those UI features and all those nice things that help us work with this data. Apex, it's kind of in a middle ground because in general, it's not so suited for working in that with data in detail as VEX involves, but it's a coding language. So we probably not even in the future we will have all those nice high level features that we have here because this is again coding language. So it's supposed to be not so high level as this, because in the end we have to store this code as geometry. So of course, side effects, they'll try to help us the way they can, but at the end of the day, this is kind of in the middle ground, and therefore we don't have those nice features, but we have, because of this, all or at least other cool features that we don't have neither here or here. That is being able to access operators in theory from every network Houdini has. Of course, they have to be available in Apex. Right now in SOPs, we can access verbs, but we have some geometry operators that are exclusively available in Apex. We can access DOPs at some extent. Probably in the future, we'll be able to access COPs as well, because the new Copernicus was built on top of Apex. So I think it's just a matter of timing. Side effects allows us to access those nodes in the general Apex language. So at the end of the day, we have a single context where we can access, again, in theory, every other part of Houdini. And that's very interesting technology. This is something that people have been arguing for quite some time, for a context where or at least a contextless way of working in Houdini. And at some extent, Apex solves that. Something like Nuke does. Yeah, you can access all those nodes from every kind of context it has in the same network. But of course, 2D nodes can't work with 3D nodes. So in Houdini, I think that wouldn't work at all because we have so many nodes. But anyway, Apex, it's kind of a contextless context. So, or an agnostic context where we can access other contexts inside the Apex. For rigging, that means we will be able to do things today are not possible, at least not in other DCCs. In Houdini, that would be possible if we start to merge those contexts in an HDA, but then we'll be tied to the HDA. Then we will need to create a UI for that HDA. We would have a lot of good sides, like being able to access those contexts, but the downside of it is creating the HDA takes time, creating UI takes time. In Apex for rigging, we avoid all of that because we are able to access those contexts, and we don't need an UI at all because for character animation, it was built to work in viewport and in the animation editor in general. So I think it's a very, very interesting approach. But that's not only all of it, because since we are saving this or storing this as geometry, that means we are not tied to a heap file. And Maya users, they know how the reference system works. And for a lot of time, it can be a nightmare. Here we are just saving the geometry. It's simple as that. And to get the rig is just a matter of getting or importing the geometry. So this is a feature that has already been built everywhere, especially when talking about pipelines. So it's the same thing as importing geometry. So this simplifies a lot the process. So I think this gives you a glimpse of Apex, not only the general idea and how it and why it matters, but what the future can bring us, well, because of this new tech. So that's it for this video. And in the next one, we will start finally working directly in Apex. So I see you next.